This is Unit 7, 7.1a activity under construction. We're going to use the program GeoGebra in order to help us do this activity. And the first explore that we end up doing in this activity is to construct a rhombus. Knowing what you know about circles and line segments, how might you locate point D on the ray in the diagram given? So the distance from B to D is the same as the distance from B to A. So task 1 has us describe how we would do this. And we're going to do this by drawing in circles that have the same radius. So draw in circles. So the tool that we're going to use to do that is the circle with center through point. So you select point B and point A, and then you can add a third point right there for BD. And we know that BA and BD are going to be equal because they're both the radius of the same circle. Okay, so that helps us locate point BD. And I can prove that BA and BD are the same length by actually labeling the distance on those. So that distance is 3.11, so hopefully BD is also 3.11. I think I need to hide this ray and add a segment here so that I can actually measure it. So I label that, and yes, it is also 3.11. All right, let's go to our next task. In task 3, it says, now that we have 3 of the 4 vertices of the rhombus, we need to locate point E, the 4th vertex. So describe how you're going to locate point E and how you know that DE, EA, and AB are all congruent. So the way that we're going to do this is by adding more congruent circles. Add more congruent circles, because we know all the congruent circles will have the same radius. So I'll add that in, because they will all have the same radius. So let's go ahead and do that here. I think we need to add what we have already done and then continue to add our 4th point. Okay, so this is going to be point C. And then we need to add E. So I'm going to add a few more circles, but I'm not going to use B as my center. I'm going to use A instead as my center. So that gives me this one, and I'm going to use D also as my center. Okay, now that I've done that, you'll notice that there's an interesting point right here where my 2 new circles have crossed. I'm going to add some line segments from A to E and D to E, and I'm going to label this up right now just to prove that all of the line segments are equal, which is what we need to construct a rhombus. And let me zoom in a little bit. And all the opposite angles are congruent, which is also true for a rhombus. So let me hide a few objects first. So let's hide that one. And then I think I'm going to end up hiding these circles just to clean it up. I need to add one more line segment there, and then I'm going to label all these line segments. They should all be 3.11, which they are, and then I'm going to label my angles, and when I select the line segments for the angles, I have to go counterclockwise because that's default. So I'm going to go with this one and then this one. So across the way at E, it should have the same angle, 40.04. So let's check it. Yep, 40.04. And then at angle A, 139.96, so D should be the same, which it is. Okay. Okay, so that proves that I've accurately built my rhombus. Now the next thing we need to do is construct a perpendicular bisector of a segment and a square. So the only difference between constructing a rhombus and constructing a square is that a square contains right angles, therefore we need a way to construct perpendicular lines using only a compass and a straight edge. We're going to do that digitally rather than by hand. So this is number 3 and 4, this next task. We'll begin by inventing a way to construct perpendicular bisectors. And it all has to do with drawing in congruent circles. So I'm going to circle with center through point. I'm going to choose R as my center and S as my radius. And then I'm going to flip-flop that. I'm going to do S as my center and R as my radius. And you'll notice that these two circles cross at 2 points. Right above and below, I'm going to add those points in. So add that point and add that point. And if I connect those with a line segment, they bisect R and S perfectly. And I can prove that it's a perfect bisection. Let's add a point right there, C. And let's label the measure of R to C and S to C, just to verify that that they are equal, that it's actually cutting RS in half. So I think I need to, in order to do that, I need to hide that line and I need to add these two segments so I can label them separately. So there it is, distance or length. So 2.19, and this should be 2.19 as well, which it is. Awesome. All right, let's summarize what we just did. Describe your strategy for locating points on the perpendicular bisector of RS. So I'm going to say added 2 congruent circles. Using R as the center and then S as the center, and then connected the intersections of the circles to create my perpendicular bisector. To create my perpendicular bisector. All right. Now that we've figured out how to do the perpendicular bisector to RS, we're going to use the right angle form to construct a square. So I need to label the midpoint of RS on the diagram as point C. All right, I'll do that first. So I'm going to do my 2 circles again as R is the center and S is the center, and then label this point A, this point B, and then do a segment that connects them. And then finally I have point C here. So what does it say? Using RC as one side of the square and the right angle formed by RC and the perpendicular line drawn through the point C is the beginning of the square, finish constructing the square on the diagram below. Hint, remember that a square is also a rhombus, and you have already constructed a rhombus. All right, so I think what I'm going to have to do is I'm going to have to do a whole bunch of circles that use RC as their radius. So that means that my center of my circle will be at C. Go like that. So it looks as if here I'm going to put a point. So I have a square starting to be built with R, C, and D, but I need one more point to finish my square. So I think I need to use another circle, but this time with D as the center. I'll build it like that. Did that help at all? Let's see. Don't see where my fourth point would be quite yet. Okay. Have I done a circle with R as a center? I don't think so. So I'm going to do another one there. R is the center and all the way to C. And I think I see my fourth point. Do you see it right here? Right there. Yeah, I think I need to hide a few things. So I'm going to hide these really large circles. And let's hide my perpendicular bisector. I'm going to have to add a segment here just so that you can see what's going on. So if I used D as my center of my circle and R as the center of my circle, where those two circles intersected, that gave me my fourth point E. Now I'm going to prove that this is indeed a square by labeling the sides and also by labeling the corners. So let me hide a few more things. So I don't need that one. Let's hide these circles. And I think I need another line segment right there. So this is the square that I ended up with. I'm pretty sure it's what I want, but let's label everything. So here we have 2.19, 2.19, 2.19, 2.19. Awesome. So all the sides are the same, which is what we want. Now we need 4 right angles. So let's use the angle tool, and we're going to go counterclockwise as we select them. So I'm going to select this bottom, and then that one, 90 degrees. Awesome. This left, and then the top, 90 degrees. Top and right, 90 degrees. Right and left, bottom. All right, we have successfully created a square. Awesome. All right, let's go ahead and finish our takeaways. I use circles and lines as construction tools today. Take notes as appropriate below. Circles are useful construction tools. Why are they useful construction tools? Well, the reason why they are so useful are because the radius of a circle never changes, regardless of where you're looking at the circle. So the radii of a circle are congruent. So let's say that. The radii, so it's like multiple radiuses of a circle, are always the same. That's congruent. Which is very helpful because I can vary where my center is and use the same radius and get congruent circles. Okay, the radii of a circle are always the same congruent, which allows us to construct congruent segments. All right, so that's our takeaway about why circles are useful. Congruent circles are useful construction tool because the radii are always the same, which is pretty much what we just said for the last question, but let's rewrite it. The radii of congruent circles are always the same. Okay, and then the last takeaway has to do with the congruent circles in the construction of the perpendicular bisector. Help me notice help me notice. What did they help me notice? They help me notice that the points on the perpendicular bisector are the same distance from the endpoints of the segment. Oh, that's interesting. Are the same distance from the end points of the segment. And I think that means, let's go back and look at the perpendicular bisector for a moment. So if we look at this right here, and I'm going to hide for a second this one and then add two separate segments. Those two are equidistant. So let's check it. 3.79, yeah, that's true. The points on the perpendicular bisector All right, so a lot of like interesting patterns happening and throughout this whole entire activity. I hope that helped you with 7.1a, and I wish you good luck on your Check Your Understanding practice.